Hello, Software Guy here with a new video, and today we're diving into an advanced guide on how to get the most out of the latest version of lossless scaling. If you want to squeeze out extra performance, boost your FPS, and enjoy smoother gameplay without spending a dime on new hardware, this video is for you. We're going deep into how to use the new frame generation system, how to unlock hidden potential from your integrated graphics card, how to combine FSR Upscaling with frame generation for better performance and image quality, and how to put it all together for the ultimate gaming experience. Each method comes with its own setup requirements and tips, so make sure to stick around until the end for everything to work smoothly. Let's kick things off with frame generation. Frame generation is a technique that uses motion vectors to create additional in-between frames. This means your GPU renders fewer frames, but the software fills in the gaps, giving you higher FPS without needing more rendering power. With the latest update to lossless scaling, make sure your model is set to LSFG 3.0, the newest and highest quality algorithm available for frame generation. If you're using fixed mod, you'll be able to pick from preset multipliers, like 3x or 4x. You can even push it up to 20x. But for that, it's critical to cap your base FPS to a stable number that your system can handle at least 90% of the time. I recommend using Ravituner Statistics Server, RTSS, to set that cap. A stable 30 FPS base is usually the minimum you want to maintain in order to get good quality interpolated frames. One of the biggest upgrades in this version is the addition of adaptive frame generation. Before this, fixed frame generation worked purely by multiplying your base FPS. So if your game ran at 30 FPS and you set it to 2x, you'd get 60 FPS. But if your FPS dipped to 25, your effective output would drop to 50. Even worse, fixed mod only supported whole number multipliers like 2x, 3x, all the way up to 20x. So if you wanted to hit something specific like 144 Hz, you had to cap your base FPS to something awkward like 72, which wasn't always ideal. Adaptive frame generation changes that. Now, you can target any FPS you want, regardless of your game's fluctuating frame rate. The scaling adjusts on the fly to help you hit your desired target. This removes the need for those strict multipliers and allows for a much smoother and more flexible experience. However, a quick heads up, fractional multipliers like 1.5x or 1.8x don't necessarily reduce the workload compared to 2x. In fact, they can often use just as much GPU power, or even slightly more, since more frames are being generated versus rendered. So if you're running at 40 FPS and trying to reach 60 using 1.5x, you might as well aim for 80 FPS with 2x. The cost is similar, but the smoothness is noticeably better. Let's talk about a few technical settings and what they actually mean in practice. Flow scale. You can tweak this without affecting visuals too much, but increasing it does raise your GPU load. Find a balance that works for your system. Capture API. If you're running Windows 1124H2 or later, use WDC. If not, stick with DXGI. QTarget. You'll see this option in the new UI. It adjusts the trade-off between latency and performance. 0 equals lowest latency. Great if your FPS is capped and GPU load is low. 1 equals balanced. Best for most users. 2 equals best for uncapped/unstable FPS and high GPU load situations. If you're not sure, just leave it at 1. Here's one of the coolest tricks. Offloading frame generation to your integrated GPU. If you're on a laptop and your display is directly connected to your integrated graphics, not your dedicated GPU, you can run frame generation on the iGPU. This allows your dedicated GPU to focus solely on rendering, which can significantly boost performance. However, this only works if your monitor is your laptop's built-in screen. The screen is wired to the integrated GPU. If you're using an external monitor, especially one connected via HDMI to your dedicated GPU, this trick won't work. Let's now move on to FSR, Fidelity FX Super Resolution Upscaling. Here's the process. Lower your in-game resolution. For example, drop down to 1280 by 720 if your native is 1080p. In lossless scaling, change the mod to custom and enable resize before scaling. Adjust the scale factor to match your needs. 1.3x equals ultra quality, 1.5x equals quality, 1.7x equals balanced, 2.0x equals performance. Each one represents a trade-off between image quality and FPS. so pick the one that best suits your game and GPU. When combining FSR Upscaling plus frame generation, make sure to do things in the right order. First, remove any frame rate limit so FSR can do its job. Run the game with upscaling and set a new frame rate limit if you're using fixed mod. Then re-enable frame generation. If you're using adaptive mod, no FPS cap is needed at all. So that's the full advanced guide for using lossless scaling like a pro. Whether you're playing on a budget laptop or a high-end rig, these tips can help you get more frames, better responsiveness, and a much smoother gaming experience. If you found this helpful, give it a like, subscribe for more, and let me know what you'd like to see covered next. Thanks for watching, and I'll catch you in the next one. Peace out.